Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, we're going to look at another aspect of mechanics, which basically regards the concept of kinetic energy. Now, in our previous discussions, we had looked at the two specific aspects of potential energy, which was gravitational and, of course, what we refer to as elastic potential. And this, of course, shed for us a light on how we can represent various forces which are going to be involved in this particular aspect of potential energy and the relationship between potential energy, work, and of course other areas which we in some of the cases of course mentioned this aspect of kinetic energy. Now in this case, this kinetic energy is basically the energy that's going to be, or the quantity that's going to be associated with the motion of particles, and this is going to be differentiating it from our first of course discussion on the concept of potential energy, which dealt with particles at rest or a static aspect of particles. Now in this case, we're going to consider a particle of mass m moving under an action of a constant force, whereby we're going to use this specific initials in trying to find a way of representing this aspect of kinetic energy. In this case, we're going to consider, as I've said, a particle of mass m. And this particle of mass m is going to be moving under the influence of a force. In this case, if this particle m moves under the influence of a force given in terms of F, so this is going to be a vector quantity that I'm going to give as such. So kindly take note of these particular initials which we are going to use. They are going to assist us in our final case in trying to represent this aspect of kinetic energy. Now, considering this specific force that is going to be acting on this particular particle, we're going to see that, of course, we can consider this from Newton's second law of motion, whereby if this force is going to be considered as a constant force, particularly we can have this one represented using a relationship of a force is equivalent to mass times acceleration. And from Newton's second law of motion, then therefore this is going to be giving out this specific relationship. Now, if this particle is going to be displaced through a specific distance, now we're going to consider this specific displacement, perhaps giving it an initial of d, which is going to be the displacement from the initial to the final position of this one. So we can consider the work that is done by this specific force in moving this object from the initial to the final position, and therefore this is going to be constituting the summation of the elements of work, which is equivalent to the summation of the forces which are going to be involved, or all elements of force which are going to be forming this final aspect of the constant force times the distance, which is a displacement given in terms of a d. So this is going to give us an element of work done by this specific force in trying to move this specific particle. And from Newton's second law of motion, and then therefore we're going to see that this is specifically aspect of the summation of forces we're going to consider, whereby F is equivalent to the summation of the force elements which are going to be involved. So we can give this one even in terms of this specific relationship, whereby this one as well, Fi is going to be a vector quantity given as such. So considering this specific case for the forces, element of forces, then therefore we can do an evaluation for this one by doing a substitution, whereby we're going to have this element of work given in terms of that specific aspect of a force times the distance. And therefore, from Newton's second law of motion, we can do a substitution for this one and have the summation of W equivalent to MA times the distance given as such. So in this case, we can consider that one. And of course, if this particle is going to undergo a constant acceleration, we're going to consider this aspect of acceleration. If this particle is going to undergo a constant acceleration, then therefore we can have from equations of motion, we can have our displacement given in terms of this specific aspect of velocity, whereby we're going to have the average velocity given in terms of Vi minus Vf. So this is going to be velocity initial plus the velocity, of course, final times 2. So this is going to be velocity, average velocity times time. So that's going to depict a displacement, whereby this d is given in terms of the average velocity times time if this acceleration is going to be considered to be a constant. Now we're going to see that as I had defined, this is going to be the initial speed and the final one, given using those specific aspect. Then therefore we can have this specific element of a work which we are given in terms of summation of W is equivalent to m mass times acceleration times distance, and therefore this is going to give us this specific element of work given in terms of so we're going to have mass but in this case acceleration, we had defined acceleration as the rate of change of velocity with respect to time. So if we consider the rate of change of velocity, that is going to be of course the velocity final minus the velocity initial with respect to time, and this is going to give us an element of acceleration in this particular case. And then therefore we're going to multiply this one times the distance which we have given in terms of average velocity times time, and therefore that's going to give us Vi plus Vf all over 2, and this is going to be given as times time. So that's going to give us an element of the work done, and this basically, in trying to evaluate this one, we're going to have this one given in terms of so we can see some of the common factors in this multiplication, and therefore we're going to have that common factor over this one given taken out, which is going to be half m, and then we are going to have V squared minus V initial. So this is going to be the velocity final squared minus velocity initial squared given as such, and this is going to be the element of work done given as such. So we can consider the case whereby we're going to have this specific aspect of V, whereby V can be defined. So let's have this one a continuation where V can be defined as V final minus V initial, and therefore the square of this one basically is going to give us V final squared minus V initial squared given as such. So we can have this substitution taking care of this specific section, and therefore we're going to have this work given in terms of half mv squared given as such. So in this case we had looked at one of the aspects of this specific kinetic and potential energy, and we're going to see that the change in potential or the change in kinetic energy can be given in terms of this specific element of work, whereby we're going to see that this element of work or the change in this element of work is going to be the change in kinetic energy, which is going to be given still as half mv squared. So in this case, this is going to assist us in trying to define the concept of a kinetic energy, considering this specific displacement of this particle. And therefore, we're going to see that the kinetic energy, basically, as I had mentioned from my previous statement or opening statement, is a quantity that is going to be, or the quantity of energy associated with the motion of a particle. And generally, it can be given using this specific representation. Now, I've mentioned this particular formula, which given in terms of, let me just show this one on the board. So I've been evaluating this specific element of work, or summation of the elements of work given in terms of W. So this is going to be the difference or the change in kinetic energy given in terms of kinetic initial minus kinetic final, or kinetic final minus kinetic initial given as such. So this is going to form another important element of the representation we're going to come across in our various discussion, and this basically is what we refer to as the work energy, or the work energy theorem, or the work kinetic energy theorem in some of the literature. So we're going to do an elaboration on that one in case we come across them. But that's going to be a relationship that is going to hold that the element of work is the difference in kinetic energy, which can as well be given in terms of half mv squared. So in case we have two values for the initial and final for kinetic energy, and therefore that's going to give us the work energy theorem even in this particular fashion. So kindly check our description boxes for various links of other videos. Subscribe and engage us in the comment section, and also ring that notification for other updates we are going to do in science and mathematics. So that is it for now, guys. Bye, God bless you. Catch us in our next video.